Hello, we talked about inventory simulation in our previous video. In inventory simulation, our demand was uncertain, so that's why based on our demand, we had to decide whether to order new inventory or not. Based on that decision, we calculate ordering costs and holding costs and finally total cost. So in this video, I would like to talk about EOQ model, which is economic order quantity model. And here, the idea is very similar to simulation, but we assume that the demand is not uncertain anymore. If the demand is not uncertain, and if I use the average demand, what would be the best ordering quantity? So what I'm gonna do is, I will copy this section right here, given information. And then I will create a new Excel sheet, call it EOQ, economic order quantity. And I will paste that information here. So I have this given information. And now I would like to build my model, EOQ model, based on this, okay? I can maybe even copy the model title here, right here. Beautiful. So I would like to just introduce a new parameter here, which is unit purchasing price. Unit purchasing price. All right. So unit purchasing price, I will abbreviate this one as PU. All right, PU. And before moving the model, maybe I can define these parameters. So here, average demand, I will denote this by small letter d. Okay. And then average holding cost, I will denote this one as capitalized H. And ordering cost per order, capitalized S. Reorder point is ROP. And so based on these parameters, I will build my model. So in EOQ model, let me just calculate the steps here. So step number one, I will calculate the economic order quantity. And the formula for this is, which is Q star equals to square root of 2 times capital D, which means annual demand, not daily demand, times capital S, ordering cost per order, divided by capital H, which is holding cost per unit per year. So if I use this formula, I can calculate my economic order quantity. So let's do that. Square root of 2 times capital D. I don't have capital D, but I have small d. To calculate the capital D based on small d, I can multiply that per day demand with number of days in a year. That will give me capital D times capital S, ordering cost per order, which is right here, $200, divided by capital H, which is holding cost rate per year. That would give me my best order quantity. So if I just run this number, it is around 171 purses, right? 171 purses. And that kind of makes sense. If you look at inventory simulation, we say that somewhere between 150 and 200, and the exact quantity is 171 purses. So that's the best number of purses that I should order, which will minimize my cost. All right, so step number 2, you don't have to go through these steps all the time, but I would like to show you how to calculate total cost based on inventory holding costs, ordering costs, and purchasing costs. So let's calculate number of orders per year. Number of orders per year. And I will denote this one as capital N is equal to annual demand divided by Q star. Right, Q star. Beautiful. So annual demand divided by Q star. All right, so let's move on. So let's calculate this. My annual demand is not given to me again, but I know demand per day times number of days in a year. That would give me my D, capital D, times, not times, divide by Q star, economic order quantity, which I calculated right here. All right. So it is, as you see here, I need to order 43 times in a year, right? Number of orders per year is 43 times. Beautiful. If you want to be more specific here, this is 171 purchases per order, and these are number of orders per year. All right, so let's go to the third step. Here I would like to calculate the time between orders. All right, so since I have 365 days, if I divide this value by number of orders per year, that will give me number of days between my orders. So roughly 9 days between my orders. All right. Let's go to step number 4. Here I would like to calculate the annual ordering cost. And I can calculate this by capital N times ordering cost per order, which is capital S. So capital N, number of orders per year, I calculate that already, 43, times ordering cost per order, which is capital S, $200. So you can see that my annual ordering cost is around $8,544. And this is again dollar per year. All right, step number 5, I would like to calculate my cycle, or in other words, average inventory. My cycle inventory or average inventory is my Q star divided by 2. Q star divided by 2. The reason is that Q star is the economic order quantity, and if I divide that value by 2, that would show me on average how much inventory do I have. Okay, so Q star divided by 2, let's calculate that. Again, the assumption here is that I will receive my inventories whenever I have 0, and then I will order Q star amount, which is 171. So my inventory position will reach from 0 to 171, and I will start consuming it again, and it will go back to 0. And the average inventory is gonna be the average of those two. So if I want to just maybe show you the intuition here quickly. So let's say this is my inventory position, and these are my days. So my inventory position will start from, let's say, Q star, and it will start going down, 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 and then when it reaches 0, it will go up again to Q star, and then it will go down, 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 and then it will go back up again, Q star. So the average inventory is Q star over 2. The reason is that that's the average inventory, because we assume that the demand per day is constant. So as you see, the slope here on this line is constant, right? So my cycle or average inventory is 85 purses. Right? Let's go to step number 6. Here I would like to calculate the annual holding cost. And my annual holding cost will be holding cost rate, which is capital H, times cycle inventory, which is Q star over 2. All right? So let's make this calculation right here. Capital H is $100 times my Q star over 2 is 85. So my annual holding cost is $8,500. Right? And as you see here, this and this, ordering cost and holding cost, should be equal because that's what we said. The intersection point between ordering costs, if you look at the previous slide or presentation, actually the intersection point right here should give me the lowest cost. Of course, this is a random model. That's why the lowest cost somewhere here, it may not one-to-one match, but if the demand was constant, this intersection point should give you the lowest total cost, right? So that's why in EOQ model, when my ordering costs and holding costs are equal, that's the point where I can minimize my total cost. Right? In step number 7, I would like to calculate the annual purchasing cost. This is something new. I was not considering this in my inventory simulation. Annual purchasing cost. So in this model, as you see, as you understand, we are purchasing these components or products from our suppliers. So my annual purchasing cost is nothing more than annual demand times unit purchasing price. All right, so my annual demand is my daily demand, small d, times number of days in a year, which is 365 in this model, times how much am I paying per unit. So this is right here, which I haven't put that number yet. I will put that number now. So unit purchasing price, PU, is $40 in this problem, okay? $40 per purse. All right, so my annual purchasing cost is then $292,000. All right, finally, I would like to calculate my total cost, total annual cost. So this is equation 4, 6, and 7, which is my ordering cost plus my holding cost plus my annual purchasing cost. So if you add them up, you will see that, again, these are dollar per year. So my lowest annual cost is $309,088, assuming that my demand is constant, which is 20 purses per day, based on these parameters. Of course, if the parameters do change, this situation will change. But as you see here, economic order quantity model assumes the constant demand and will give you the lowest possible cost possible. And we found that the best decision in this case is to order 171 purses whenever we order. That's it for this video. I hope you enjoy supply chain management.